Okay, here we go again. This infinity problem again that maybe someone could explain. Let's go look at our next part of the assignment, which is completing the square. Okay, it looks like this. You guys will be responsible for doing this section. There's 9 questions on there, and that's going to be due on Tuesday, our next class together. So I'm just going to screen grab this and then we'll start marking it up. What is completing the square? It's an algebraic process used to write a quadratic polynomial in vertex form. Okay, so basically we're going from standard to vertex. You guys already know how to go from vertex to standard. You basically just expand everything. Okay, but when you're going standard to vertex, there is a few things that you need to know. Okay, so we're going into the form y is equal to a x minus p squared plus q. Okay, now there is a link to a YouTube video here, guys. If you want to watch it this weekend, you can. The person who does this YouTube video solves things in a different way than I do. Maybe you like their way of solving things. Maybe you want to use my way. You can choose for yourself. And during math help, Miss LaValle shows actually a completely different way. She uses some kind of a square method. Okay. But why in the YouTube video can we not factor the function x squared plus 6x minus 1? And that we're not going to write it down, but it's basically you can't have numbers that multiply to -1 and also add to 6. It's basically impossible. You can't have it, right? So in order to solve this, we're going to complete the square. Now, what that entails is first, we're just going to look at the first two pieces of the function, which is an x squared and a 6x, okay? And what I'm going to do is I'm going to cut those pieces in half. Okay, so I'm just going to say y is equal to, when I cut in half x squared, I've got an x, and I'm going to cut in half 6x plus 3. Okay, so that's the first major part. And we're halfway done right now. Okay, now we've still got that -1 there. We didn't do anything to it. But just as an aside here, I'm going to look at x plus 3 squared. Okay, so I'm just going to bring it over here. Of course, x plus 3 squared, you guys know, is x plus 3 times x plus 3. Okay, and I'm going to show you why this method works so good. So if I was to FOIL this out, I'd have x times x, which is x squared. Okay, and then I'd have x times positive 3, which is plus 3x. Okay, and then I'd have 3 times x, which is another positive 3x. And then I'd have 3 times 3, which is positive 9. Okay, so let's just take a quick little gander here. We have an x squared. Our original function had an x squared. That's good. Of course, this 3x plus 3x, that's equal to 6x. Okay, and if I look, our original function had a 6x. I've also got this extra piece right here, which is a plus 9. That's not good. Our original function didn't have a plus 9. It had a -1. So what I'm going to have to do with this is subtract 9. Okay. So what I'm going to do is I'm going to minus 9 here. And what I'm going to get is y equaling x plus 3 squared minus 10. Okay. Now, a good way you can check that, let's look at the original function, x squared plus 6x minus 1. Can you think of a good way to check it? If you said to graph it, you are correct. So let's go back to handy dandy Desmos. Okay, and we're going to say y is equal to x squared plus 6x minus 1. Okay, so we graphed it, and we want to check the vertex. The vertex, if I look back on my screenshot, it should be at -3, -10. Okay, so let's check that vertex. And we'll just zoom in there. There it is right there, the vertex, -3, -10. Everything's looking really good. Okay. Now, if we look further on down the assignment, so you guys know, this right here, this is what's called completing the square, and this thing in yellow is the final answer. Okay, so we have completed the square with this quadratic function. Okay, try completing the square on the following. What would be the coordinates? And I should put of the vertex right here. So this should be of the vertex of the following. So we're going to do the same thing. I'm going to choose maybe 2 problems out of here. I'll probably do the first and the second. Okay, and then they all kind of work the same from there, guys. So let's look at the first one first. And I'll just take another screen grab of this. Okay, so let's look at this first one. Y equals x squared plus 8x. Now, the first thing, of course, you're going to do is you're going to cut in half the x. You're going to cut in half the 8. Okay, so we're going to have y equaling x plus 4 squared. Okay, now I'm going to go this way with my side so I don't mess up my room. And we don't have anything to put on the end here yet. If I look at x plus 4 squared, it's always nice, guys. You might be able to do x plus 4 squared in your head, but you know what happens a lot is students just say x squared plus 16. Okay, so what students often do is they'll take this 2 and they'll just apply it twice in there. But remember that the whole function has to be squared. So I always like to write them out like this. Okay, so let's go through x squared plus 4x. Okay, plus another 4x for this one here. Okay, and plus 16. Now that we got that all figured out, we just got to figure out what do we have. Well, if I look, we'll do it in green, x squared. Okay, I've got an x squared. 4x plus 4x, of course, that's 8x. And I have one of those 8x's. I don't have a plus 16. So what I'm going to do here is I'm going to say minus 16 just to make sure that everything's algebraically true. We haven't broken any math laws here. We should be good. Now, for the check. When we go and check it, you should be graphing this function, not the one that you just made. Let's graph the original function and check the coordinates on that. Okay, so we're going to graph the original function that we had to complete the square on. The coordinates that we're looking for, of course, is going to be -4 and -16. Okay, so let's go back to handy dandy Desmos. Okay, x squared plus 8x. And we'll look down here. There it is. The vertex, -4, -16. Okay, so we are good there. Let's do one more of those. So why don't we do this one? Yeah, those are all even. So let's do this one here. And then for the last one, I'll do a little bit of a tougher one. Okay, same thing, guys. So we've got this function. The first 2 pieces, you just cut in half, okay? So y, I'm just going to put a little line here, is equal to x minus 9. This is 9, of course, half of 18, squared minus 59. Okay, my writing's getting bigger as I go along. Okay, now I'm going to take this piece as an aside. I'm just going to do it down here. X minus 9, x minus 9. Okay, Oh, let's FOIL that out. X squared is the first. The outside terms is x times negative 9, so that's minus 9x. And then the inside terms is, again, negative 9x. And the last terms, negative 9, is a positive 81. Okay, and then we'll just check here. Let's use pink. Okay, I've got an x squared. I see here I have an x squared. This turns in, this whole thing is minus 18x. I've got a minus 18x, so that's good. I have a plus 81. I notice over here I have a minus 59. So I'm definitely going to have to minus 81 from the entire function. Okay, so I'm going to minus 81 from here. Negative 59 minus 81 is 59, 60, 60 plus 80. 8 and 6 is 14, so that'd be 140. Okay, so our final function in green again is y equals x minus 9 squared minus 140. Okay, and we can check that function again. X squared minus 18x minus 59. If we go into handy dandy Desmos, x squared minus 18x minus 59. Okay, we zoom way out because we're way down here this time. There it is, 9 and minus 140. Okay, so that's can be pretty handy for you guys to figure out. When I look at the assignment, there is some fractions here. Just use your regular fraction laws. You may get some that are odd numbers here. So like when you break this 9x apart, you're going to get 9 over 2x. Okay, that's okay too. There is one that I want to do with you guys. It's not in here, but it's going to help you out on your assignment with 8 and 9 because those two, if you look, we can see that our a's are not equal to 1. Okay, but there is a little trick you can use. So I'm going to open up the paint again here. Okay. So I'll just choose a marker. We'll use a function that we'll just make up. We'll call it, how about 7x squared minus 21x plus 70. Okay, so make sure you got another piece of paper and write this one down. I'm going to leave it up here. You can write it down. You may even want to listen for a minute and then write it down afterwards once I'm done. Okay, so of course this is y is equal to that. Let's make that a weird looking y. Okay, first thing I notice about this, guys, is that each coefficient is divisible by 7. Okay, so I'm going to factor out a 7 out of each piece. When I factor out a 7 out of the first, I'm left with x squared, which is nice. Out of the second, I'm left with the 3x. Okay, and out of the third, I'm left with a 10. Okay, now I'm just going to work inside the brackets here, guys. So I'm not going to expand anything. I'm going to work inside the brackets using the same kind of thing we were doing before. Okay. Let's put up another square bracket here just to keep things even. Let's break up the first two terms. So x minus, and I'm going to cut that in half. I'm just going to say it's 3 over 2 squared. Okay, and I still got that plus 10 kicking around. Okay, let's do an aside now. I'll choose this color. So x minus 3 over 2 squared, let's just multiply that out and see what we get. Now, because this one has fractions, it's going to take you a little bit longer to multiply it out, okay? But it works the same way. So my first term is x squared, okay? My second term is minus 3 over 2x. My third term is minus 6 over 2, or minus 3 over 2x. Okay, and then if you remember your fraction laws on multiplying, it's top times top, bottom times bottom. So I'm going to have a positive 9 over 4. Let's just leave it like that. Okay. Now let's make this a little bit easier to look at. So I'm going to have x squared minus 6 over 2 x, which I think happens to be 3, plus 9 over 4. Okay. Instead of saying 6 over 2, why don't we just say 3 here? Okay, so let's look. X squared, I've got an x squared. Minus 3x, I've got a minus 3x. Plus 9 over 4, I've got a plus 10. They're not even close to the same. Okay, so I'm going to have to subtract 9 over 4. Okay, so I'm going to say 7 x minus 3 over 2. Close the bracket and put the little 2. Minus 9 over 4. Okay, and then instead of saying plus 10, I'm going to turn this into a fraction over 4. Okay, and in order to turn a 10 into a fraction over 4, you just multiply 10 by 4, which is 40. So I'm going to say it's plus 40. And then you just keep the 4 as a denominator. And that's it. 40 over 4, you guys know that 40 divided by 4 is 10. Okay, close the big bracket. Okay, let's put these fractions together. So when you're adding, subtracting fractions, I know everyone always likes little reminders on fractions because they're annoying. But just remember that you do whatever it is on top, bottom stays the same, right? It's like you're adding pieces of pie. Okay, so big bracket. Oh, inside bracket, x minus 3 over 2 squared plus 31 over 4. Okay. And at this point, we could probably... no, we can't do that yet. Okay. So we're almost there, guys, except for this 7. We actually need to pull this thing out because it's still not in vertex form. So what we're going to do is we're going to use this 7 and apply it to the 31 over 4. Okay. So final answer, what you're going to get, okay, is 7 bracket x minus 3 over 2 square that up. Ba-ding. Now, when you take this 31 out over 4 out of the brackets, you have to multiply it by 7. Okay, so 31 times 7 is 217. So here you're going to have 217 over 4. You may want to put this into a mixed fraction now. And I'm just going to check my math on that really quick. 31 times 7. Okay. 31 times 7 is, 217. Okay, and I know that 4 goes into 7 54 times with a remainder of 1. Okay, so instead of 217 over 4, we could say 54 and a quarter. Okay, so that was a lot of stuff. But what can we see? We can see that we have an upward parabola because this A is positive. It has a vertex of plus 1.5 or 3 over 2. Okay, so plus 3 over 2 or 1.5. And then the y coordinate of the vertex is 54 and a quarter or 54.25. Let's stick with fractions. 54 and a quarter. Okay, let's check it. So we'll go to Desmos. 7x squared. I'm just writing it down right now. Okay, let's just check that the vertex is 1.5 and 54 and a quarter. Now this is a pretty complex completing the square, but it's one that you guys should definitely try. So there is a couple of examples in there for you to try. I don't think that they get quite as big as this, like in terms of the fractions, but don't be scared of them, guys. You just go through them the same way. Okay, if you got to hit a couple numbers on your calculator, do some multiplying, go ahead. Get used to the fractions because they're sticking around. Okay, what's going on here? Oh, here we go. Okay, here's the moment of truth. Oh, we got it. 1.5 and 54 and a quarter. Good. Okay, so I'm going to go back to that just so that when the video stops, you can write that down, or maybe you want to play it again. Go through it a couple of times, make sure you understand it. Of course, that's not even what we were looking at. It was this, okay, which looks even more terrible when I go back to it. But hopefully, if you go through it slowly, it'll open itself up and you guys will be able to understand that. Okay? Have a good weekend.